Alright, in this video we're going to talk about different temperature scales, the two main temperature scales, and how we can convert back and forth between those two scales. So first of all, what is temperature? Well, temperature is a measure of the average kinetic energy of the particles in a substance. So what this tells us in kind of simple terms is how fast the particles are moving. So a particle has a lot of kinetic energy, or any object has a lot of kinetic energy if it's moving really fast. So the faster it's moving, the higher its kinetic energy, the higher temperature a particle is going to have. So if we think about this kind of question down here, if we compare an object that has a temperature of 97 degrees Fahrenheit with an object that has a temperature of 46 degrees Fahrenheit, what could we say about the particles of the object based on those two temperatures? So if you want to pause the video real quick and think about this question on your own, basically as long as the substance is the same, as long as we're comparing let's say iron to iron at these two different temperatures, or gold to gold, or whatever the substance may be, as long as it's the same, we can say that the higher the temperature is, so in this case 97 degrees would be the higher temperature, the higher temperature is going to indicate that the particles are moving faster. Alright, so the higher the temperature, the faster the particles are moving. So because this object at 97 degrees Fahrenheit has a higher temperature, we can say that its particles must be moving faster. So even solids, we've talked about the three phases of matter, right? Even solids, the particles are moving. They're kind of next to each other, kind of vibrating back and forth like this, just really moving around, real tiny vibrations real quickly. But the higher the temperature is, the faster those vibrations are going to be. Okay, so the two main temperature scales that we're going to deal with here, Celsius is the temperature scale that's used in most of the world, except for the United States and a few other countries here and there. But Celsius is really, it's kind of the universal temperature scale aside from in the United States. So a couple of important benchmarks for the Celsius scale. 0 degrees Celsius is when water freezes. So the Celsius scale is actually based on the freezing point and boiling point of water. So 0 degrees Celsius is where water freezes, and 100 degrees Celsius is where water boils. So those are the two main temperatures that you need to kind of keep as benchmarks for the Celsius scale. And then the Fahrenheit scale, this is a scale that's used in the United States. It uses the benchmarks of 32 degrees as the freezing point of water and 212 degrees as the boiling point of water. So you can tell it's kind of a lot more useful in science class to use the Celsius scale when we have these kind of more easy benchmarks to use for the freezing point and boiling point of water. But the two temperature scales, you need to know both. Really, in science, we're mostly using Celsius or another scale called Kelvin, but Fahrenheit is what you'll see on the news every day in the United States for the weather and things like that. So comparing some of the temperatures on the Celsius and Fahrenheit scale, the boiling point, like we said, was 212 for Fahrenheit and 100 for Celsius. Think of normal body temperature, that's 98.6 degrees in Fahrenheit and then only 37 degrees in Celsius. Room temperature, so this is where it really gets confusing when you look at weather reports and things like that. If you see Celsius and Fahrenheit, room temperature, comfortable temperature, is 68 degrees Fahrenheit, whereas Celsius it's only 20 degrees. So you look at this on the news and you maybe see the weather in Celsius and you think it's really cold out, but actually it's not. It's just a different temperature scale. So you need to kind of be cognizant or thoughtful about these different temperature scales and how they actually are quite different in their values from one another. Okay, so the formula for converting from Celsius to Fahrenheit is Fahrenheit, or F in this case, is 9/5 times C, our Celsius temperature, plus 32. So this is C is our Celsius temperature, and then F is our Fahrenheit. So if we have the Celsius temperature, all we need to do is plug it into this variable here for C, and then do the math and solve for F. Our Fahrenheit variable, well, in this case it's already solved for, so all we have to do is just plug in Celsius, do the math, and solve from there. Alright, so you need to know this formula for converting temperature scales. So we're going to do a couple of practice examples here. So what is the temperature in Fahrenheit if we have a Celsius temperature of 55 degrees Celsius? Alright, so we're looking for the Fahrenheit temperature, F, so that's going to be our unknown. So we have our temperature in Celsius as 55 degrees, so all we have to do is take this 55 degrees and plug it straight in to the Celsius variable here. So we do 9/5 times our Celsius temperature, which is 55, plus 32. And again, we can bring our Fahrenheit variable down. So we already have Fahrenheit by itself solved for here. So now we just need to do the math here. The key with these temperature formulas, and please, please, if you watch nothing else in this video, listen to this, you need to use order of operations. So remember from math class, PEMDAS, right? So you need to use PEMDAS when you're doing these formulas. So the first thing we need to do here, right? We have parentheses, exponent, multiplication, division, addition, and subtraction, right? So the first thing we need to do here is multiplication and division, right? They come before addition and subtraction. So you do not add this 32 before you multiply and divide here, right? So we can multiply 9/5 by 55, and this would give us 99, and then we can add the temperature of 32. So we need to do the multiplication and division first, and then we can do the addition and subtraction. So we could bring this down here, and we'll end up with a final temperature here of 131 degrees Fahrenheit. So the key is, with this temperature formula, first, you take whatever temperature you have and plug it into the appropriate spot in the formula. So here we had degrees Celsius, so this goes in the Celsius spot of the formula. So once you plug it in, you just have to do the math, and when you do so, it is imperative, it is key, it is crucial that you use PEMDAS. Alright, so we had to do the multiplication and division first, and then the addition. Okay, so here's another example of Fahrenheit to and Celsius conversion. If you want to maybe pause the video and try this one out on your own and see if you can come back and get the right answer. So here we have a temperature of 20 degrees Celsius. So again, we're just going to take our Celsius temperature and plug it into the Celsius spot in the formula. So we have 9/5 times 20 degrees Celsius plus 32. So again, to solve here, we already have Fahrenheit by itself over here. All we need to do is do the math on the right side of the equation. So 9/5 times 20 degrees here, that would give us 36, and then we can add the 32. So here, if we add these up, we should end up with 68 degrees Fahrenheit. So again here, what we had to do with this formula is first do the multiplication and division, again following order of operations, PEMDAS. First do the multiplication and then do the addition. So again, the key is we plug our temperature into the proper spot in the formula. We had Celsius, so that goes in the Celsius spot in the formula. So if we want to convert from Fahrenheit to Celsius, the easiest way to do this is to just use this formula, which is basically the reverse, the inverse of the Fahrenheit formula that we had before. So Celsius equals 5/9 times Fahrenheit minus 32. So there's an important difference with this formula, and you'll notice we have parentheses here. Alright, so the parentheses, based on PEMDAS, the parentheses need to come first when we're doing order of operations. Right? So the first thing we're going to do when we use this formula is do the operation inside the parentheses here. So Fahrenheit minus 32 will be the first thing we do when using this formula. Okay, it is also possible to just use the previous formula that we had here, to just use the Fahrenheit formula here to also calculate your Celsius temperatures as well. And if you have advanced math skills, then this is great practice for your algebra use. But if you aren't so great with algebra, then you can just memorize both formulas and use the Celsius formula specifically for when you're looking for Celsius temperatures. Okay, so if we try out an example here, we have a Fahrenheit temperature of 77 degrees Fahrenheit, and we're looking for the conversion to Celsius from that temperature. So again, the same process is going to apply here. This time we have a Fahrenheit temperature, so it's going to get plugged into the Fahrenheit spot in our formula. So we can plug in the Fahrenheit temperature and fill in the rest of the formula here. So we have 5/9 being multiplied out in front here. So again, the key to this formula, and to any formula really, is following order of operations. So we have PEMDAS here. We need to follow order of operations. As we do this, the first thing we need to do is parentheses. So the first thing we're going to do is solve the parentheses expression here, 77 minus 32. That would give us 45. then all we have left here is multiplication. So following order of operations, what we have to do here is just multiply 5/9 times 45, and this would give us a final temperature of 25 degrees Celsius. Okay, so again, the process is the same. Take whatever temperature you have and plug it into the formula in the appropriate spot. So in this case, we had Fahrenheit. It goes into the F spot in this equation. Okay, so a second example, if you want to maybe pause the video and try this one out on your own. We have a temperature of negative 13 degrees Fahrenheit, and we're trying to convert that to Celsius. So don't get fooled by the negative sign here. It's a number like any other number, it just happens to be negative. So what we have to do here is, again, plug our Fahrenheit temperature into the F spot in this equation. So we have negative 13 minus 32, and we have the 5/9 out in front to find our Celsius temperature. So again, the key is following order of operations. We have to do what's inside the parentheses first. So we have to do negative 13 minus 32. So be careful with your signs and your negatives here. When we do negative 13 minus 32, this is going to give us negative 45. So again, we started with negative 13. If we're subtracting 32, you need to get more negative, right? So we end up with negative 45 here, which is more negative than negative 13 because, again, we subtracted a number here. So please be careful with this. If you ended up with, let's say, 19 for your number here, you did not do this right. You need negative 13 minus 32, which means your number should end up more negative than it was to begin with because we subtracted 32 here. All right, so negative 45 is what we end up with in the parentheses here. And we have 5/9 out in front again. And to solve this, it's going to be the same as before, except now we have a negative number here with a negative 45. So we multiply these two together and we end up with negative 25 degrees Celsius for our final Celsius temperature. All right, so in summary, using these formulas, you need to plug in the number that you have in whatever variable spot is appropriate. So in this case, we have Fahrenheit, we plug it into the F spot in the equation. If you have Celsius, it goes into the C spot in the equation. So plug the number into the proper spot in the formula, and then just do the math from there, keeping in mind the most important thing when you're doing this math is to follow PEMDAS, so use order of operations properly. Alright, thanks for watching this video on temperature conversions, and I'll see you in the next one.